Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss about amplitude shift keying under the Unit 3. So in main, these are the main classifications of digital to analog conversion. So based on the methodology of working, the digital to analog conversions are classified in three main types. One is the amplitude shift keying, second one is the frequency shift keying, third one is the phase shift keying. The combination of amplitude shift keying and phase shift keying is called as quadrature amplitude modulation. Now we can see individually in how a ASK is working and how they are generated and how they are transmitted and received. Amplitude shift keying, or simply it is called as on-off keying, is the simplest digital modulation technique. In this method of technique, there is only one unit energy carrier and it is switched on and off depend on the input binary sequence. The ASK waveform can be represented as S of t is equal to root 2 ps cos 2 pi f naught t when we transmit the data as 1. To transmit symbol 0, the signal will look like S of t is equal to 0. That is, no signal is transmitted. S of t contains some complete cycle of carrier frequency f. The symbol 1 is pulse transmitted and the symbol 0, there is no pulse is transmitted. If you see the figure, this is the digital data bit sequence, that is 1010101, and the second figure is the carrier frequency. So if the data has come in digital bit sequence, then the corresponding carrier wave is occurred, that is ASK is on. If the data is 0, then there is no signal is transmitted. If data is 1, then the signal is transmitted. If data is 0, there is no signal is transmitted. If data is 1, signal is transmitted. If data is 0, there is no signal is transmitted. So here ASK look like very simple concepts. That is, if your data is 1, then the signal is transmitted. If the data is 0, the signal is not transmitted. Simply it is called as on-off keying. So this is the another example of ASK waveform. Now we can see how this can be transmitted. So this look like ASK generator. If you see, the product modulator will receive two input. One is the binary data, that is zeros and ones in the form of B of t. Then the second one is the carrier, which is the value of root 2 ps cos 2 pi f naught t. Both these are product modulator and the output will be as binary ASK signal. So this figure shows the ASK generator. The input binary sequence is applied to a product modulator. The product modulator amplitude modulates the sinusoidal carrier. So here it is a sinusoidal carrier. It passes the carrier when the input bit is 1. It blocks the carrier when input contains 0. So this will make a simple process of a generating process. So simply, if the data is 1, carrier is multiplied, output here comes simply 0. So no data is multiplied in carrier side, so no data. So this look like another detailed discussion. So here carrier wave is coming, here binary data is coming. If the data is 1, then the switch is closed, then we can get the output. If the binary data is 0, simply the switch is open, so no carrier wave is added, so no ASK waveform. The ASK generator, it consists of a signal generator that produces a high frequency sinusoidal waveform, a message signal in digitized form, and a bandpass filter. The switch provided here gets open and closed according to the bits of the message signal. When the digital bit is of level high, that is 1, then the switch gets closed, that allows a carrier wave to get transmitted. That is, if the binary data is 1, then the switch is closed, then the data is allowed here. As against in case of low level, that is bit is 0, the switch gets open and it restricts the carrier wave. This is the reason why the signal appears as the output in case of high level. After this, pulse reshaping is done by the band limiting filter according to the amplitude and phase characteristics of the filter. So now we can going to see the detection process. Detection or demodulation is the process of recovering original message signal from the modulated waveform. In ASK, there are two types of detections are available. One is the coherent detection and another one is the non-coherent detection. Now we detail this discuss on coherent detection. It is noteworthy in case of coherent reduction that the carrier at the receiver must be in synchronization with the carrier at the transmitter for accurate detection. The demodulation circuitry consists of a product modulator along with an integrator and a decision making device. Here, the input to the product modulator is modulated waveform along with the sinusoidal carrier. The combination of the two is then fed to the integrator that operates successively according to the bit interval, after which it also executes low pass filter of the signal. Then the output of the integrator acts as an input to the decision device. Also, a preset threshold is provided to the decision making device. The decision device compares the input signal at its output with the threshold value. When the signal exceeds the threshold value, then the bit 1 is provided by the decision device at its output. However, when the signal reduces a low value to the decision device value, then the threshold value, then the bit 0 is achieved. So if you see this figure, this integrator will band limit the input signal, then the decision device will compare the input signal along with the threshold value. If the input signal will having much higher than threshold value means, then here the bit of data is 1. If the input signal having a very low value compared to threshold value means, here the bit is at 0. So here it is a non-coherent receiver. Instead of this using an integrator, here they are using a envelope detector which consists of a rectifier circuit along with the low pass filter. So this is the power spectral density of the ASK waveform. Then the main advantages of ASK waveform are it offers high bandwidth efficiency, it has a simple receiver design, its generation and detections are easy, thus facilitate a simple transmitter and a receiver section. ASK modulation and demodulation are relatively low cost methods. Its version on-off keying is used to relay Morse codes over radio frequencies. Digital data can be transmitted over optical fiber using ASK modulation. The drawbacks of ASK modulation are it offers low power efficiency. ASK modulation is very susceptible to noise interference because it is easily affected by noise. It is because noise has an impact on the amplitude. It has poor bandwidth efficiency. The ASK techniques are not suitable for high bitrate data transmission. The main applications of ASK modulation are it is used in digital data through an optical fiber is transmitted using ASK technique. The technique was widely used in traditional telephonic modems. So in this YouTube video, I discussed what is meant by ASK and the symbol representation of ASK, how the ASK waveform is generated, then how it can be detected using a coherent detection method and a non-coherent detection method, and I also discussed the advantages and disadvantages of ASK. Finally, I conclude with the applications of ASK. Thank you for watching my video.